Okay, review problem first off. Okay, guys, so what's the first thing you're going to do to get this from standard form into vertex form? Okay, the first thing you need to do is move your constant term to the left. So we have f of x plus 319. What else do you need to do? Okay, remember that before when we were solving we would divide by -5, but now we can't do that. We're going to factor it out. 7th period, they asked yesterday, they said there was a problem where this wasn't the GCF. So, side note, what if we had -5x squared plus 19x? Would we still factor out the -5? Yes. So it's not necessarily the GCF, because the GCF would also include the x. It's just factoring out the coefficient of x squared. So factor that out, you're left with x squared plus what? Oops, I'm sorry, minus 16. Okay? You're now set up, you're ready to complete the square. Very good. What is that? 64. So you're adding 64 on this side. We're going to put it right there. Go ahead. And then what number are you going to add on your left side? Why is it not just 64? Because you have a -5 out front. So -5 times 64 is -320. Yes, Joey? That's from the b, which is -16 divided by 2 squared. You good with that, Joey? Okay. All right, so we have f of x minus 1 equals -5 times. Finish completing the square. What is the quantity squared? Technically, what are you doing from this step to this step? You're factoring, technically, but the shortcut is just divide b by 2. One more step. Add 1. F of x equals -5 times x minus 8 quantity squared plus 1. What's the vertex? 8, 1. Good. 8, 1. Your h and your k. You have to use the opposite sign because your formula is x minus h plus k. What's the direction of opening? Down. And it opens down. Any questions on this? You are, man. Super awesome. All right, your homework from yesterday, there were lots of evens, so go ahead and check those out. You made it. No worries. Set it right there. Thank you. Nope, you're good. Homework questions. Oh, I put the odds up there too. How nice am I? Yes, sir.
29.
Okay, what was it?
Y equals 1/3 x squared minus 4x plus 15.
Sounds fun. All right, so first you're going to move the 15 over. And then you're going to have to factor what out? 1/3. So what is -4 divided by 1/3? Right, because that would just be -4 times 3, right? Same thing. So -12. Okay. Add half of -12 is, or -12 divided by 2, and then square it. Okay. So plus 36. But what am I going to have to add on the other side? 36 times 1/3, which is 12. Because we didn't just add 36, we added 36 times 1/3, which is 12. So y minus 3 equals 1/3 times, what's the quantity? X minus 6 squared. And then finally, just add your 3. And there's your equation. You can get your vertex out of that and your direction of opening. Other homework questions? Isn't this stuff fun? It's like such good algebra. I love it. Nothing else? All right, well, the next section is much easier. No, really it is. 6.7, it's the last section in the chapter. Okay, so everything we worked with so far in this section or in this chapter have been quadratic equations. When we're talking about quadratic equations, what ways did we learn to solve them? Factoring, completing the square, quadratic formula, and graphing. When we do quadratic inequalities, we will only do them one way. Any guesses? Graphing. So real quick, let's think about linear inequalities. When we graphed a linear inequality, we had to think about what type of line it was. Remember whether it was solid or dashed. And what other part did it have? Shading. Okay? A quadratic inequality is going to be that exact same thing. It's just not going to be a straight line. It's going to be a parabola. Okay, so same idea. Where are your solutions located on this graph? It's in the shading. Okay, anywhere in your shading. So it's the same thing. It's just, like I said, parabolas now. Okay, so here is a quadratic inequality. We're going to work with them generally in standard form. You could work with these in vertex form too. It's just most of the time they're going to give them to you in standard form. And we're just simply going to do this in our calculator. So pick up your calculator. From your home screen, go to your graph. Of course, if you have anything in there, menu 1, 4, enter to delete things. If you don't have a standard window, menu, window zoom, zoom standard. Okay, we press what to get up our box to type into? Tab. And then how do you change your equal sign to an inequality? Delete or backspace there. And they all pop up. On this particular one, we want less than or equal to, which is option 1. It changes it to a y. And that is because inequalities aren't functions, so we can't use function notation. And then just type in your data here, x squared minus 6x plus 2. And there it is, your parabola complete with shading. So what I will ask you to do is to do a rough sketch of this for your answers. So make yourself a coordinate plane. Definitely pay attention to whether your parabola should be solid or dashed. In this case, it's solid. And then it should be, in general, similar or close to where it actually is on your graph. So I would not be looking to see an answer like that. That's definitely not located in the right place. So put it where it goes. I just set it right there. Thank you. And then you need to also include your shading. How many solutions are there to this inequality? There are an infinite number of solutions. Is this a solution? No. Is this a solution? Yes. Is this a solution? Yes. Good. Okay, let's try another one. Does it matter that this is a 0 and not an f of x or a y or anything like that? No. Interchangeable. It does not matter. This one goes off of your graph a little bit, the bottom of it, so you can always zoom out. Menu, window zoom, window settings, you could pick particularly what numbers you want, or you can just do zoom out and hit enter, or click. You can also click on your graph and move it around, whatever you want to do. And then again, I want to see a rough sketch. Would you use a solid or dashed parabola here? Dashed. And then, of course, the shading should be inside the parabola. How many solutions are there on this one? Infinite. Yep. There's still an infinite amount inside that parabola. Are the points on the parabola solutions? No. Why were they last time but not this time? Yep. If it's equal to with that solid line, then they are solutions. And if not, then they're not. Are you guys good with this lesson? Okay. What if they phrased it this way? Let's do this one. Let's do one more, guys. So I would still want to see your sketch of your parabola. Still looking to make sure you have the right type of line and your shading is in the right place. But then in addition to that, they've asked you to name one solution. Kaden, name one solution. 0, 0. What do you guys think? Sure. Zach, give me another one. -1, -1. Absolutely. Connor Tar, give me another one.
-2, -2.
Sure. What about 10, 15? Sure. What about -4, -12? Yeah. What about 1, 1? No. So literally any point outside here or any point on the parabola would be fine, just none that are inside the parabola in this one. Any questions? All right, there is your assignment.